Hello everyone. In this video, we are going to talk about the crystal field theory in octahedral complexes. Okay, what is crystal field splitting? Okay, and then how we can find the relation, what is the derivation of crystal field splitting in octahedral complexes. We'll discuss everything in detail. So first is, what is a coordination compound? And what is CFT? Okay, see, coordination compounds are compounds where there is a central metal atom and that is coordinated with ligands. That means on the sides of it, it has ligands or neutral molecules, or you can say nucleophile, which makes an electrostatic bond between them, which is not a covalent bond but a coordinate bond where there is a partial sharing of electrons, we can say, or sometimes the ligand totally gives the electron to the system and system. Okay, so it is not covalent bond. Remember that, because here there is direct sharing of electron does not takes place. Okay, so when we go for your 3D series, okay, those elements of 3D series, these are metal ions. Okay, so the metal ions also, they form, because it is in the D subshell, they have D subshells, and these subshells, D has 5 subshells, we know. So these 5 subshells, it will split into 2 energy levels. Okay, in case of your VBT, we knew that these 5 sets of your d orbital have same energy level in your ground state as well as in your excited state, but that is not the case of your crystal field splitting. In crystal field splitting, they say that the d orbitals, these 5 orbitals, are degenerate. Okay, and they can split into 2 forms, that is your T2G and EG level. That when the coordination complex forms, okay, when the ligand approaches the central metal atom, okay, so there is 2 kind of repulsion taking place and attraction at the same time. There is an attraction between the positive metal atom and the negative ligand. So what happens is that the system lowers the energy, lowers the system. So there is an attraction, or we can say there is formation of coordination complex. The energy decreases, but at the same time there is repulsion between the electrons of the metal atom and the electrons of the ligand taking place simultaneously. So that there is a repulsion also. So when these ligand, some are your strong field ligand, some are your weak field ligand, when they approaches the central metal atom, okay, we will imagine a 3D plane of the structure. That means we are going to magnify, we are going to see that in your 3D plane, not just in a 2D plane. We are not talking anymore in 2D plane. We will imagine it in a 3D plane. So if you imagine a 3D plane, we know it has an x-axis, it has y-axis, and it has z-axis also. So if you put, suppose if you are putting the metal atom in any of in the space between the x, y, and z axis, okay, so there is if we draw it in a shape of a cuboid, we can say there is a planes. There is d xy plane, there is yz plane, there is zx plane, there is a z square plane. Okay, and then there is x square minus y square plane. So now when you have picturized a 3D model of you can say coordination complex, now you imagine what happens, that the ligand approaches this central metal atom in any of these directions. Okay, if we draw the direction of the space, so in any of this direction it will approach. Right. So what happens is that this in your CFT, it is said that the d orbitals, it has 5 rooms, so it splits into 2 room and 3 rooms. Means like it splits into 2 and 3. It splits into your EG level, which has two sets, that is your dx z square plane and dx square minus y square plane. Whereas in T2G level, it has 3 sets, that is dxy, dyz, and dzx plane. Okay, so what happens is that in your octahedral complex, or you can say when the ligand is your strong field ligand, when it comes and approaches the central metal atom along the direction of x dash, y dash, and z dash. Okay, and it is not it is directly approaching, so d z square, okay, and d square minus y square. So these two are facing the highest repulsion, hence their energy will be very much high. Okay, so in the diagram we will see they are placed above, and whereas in the direction of dx square, xy, dyz, and dzx, there is no ligand which is approaching in these direction, so their energy will be low. Okay, so these are your three lobes which is drawn in the lower state. So the d orbital in crystal field theory splits into five degenerate orbitals, that is your dxy, dyz, dzx in T2G level, and dz square and dxy minus y square in your EG level. Okay, so we will now go for the derivation of the energy. So there is you can say the energy difference is there between your T2G level and your EG level. So when they form the maximum repulsion, this time there is a formation of octahedral complex of your crystal field splitting in your octahedral complexes. So initially energy of the 5d orbital increases equally in a uniform or spherical field as the ligands start approaching the complex. So initially the energy is equal, okay, there is no problem, but as the ligand forms the complex, okay, as the ligand starts forming the complex coming near, the splitting of the d orbital takes place. That time there is an energy difference, okay, between your EG level and your T2G level, okay, and that is known your crystal field splitting or your delta naught. So if you draw the graph, see here this energy, okay, and this side is your octahedral field. So there are 5 energy level, 5 lower degenerate d orbitals which does not have any energy right now, and then they are of equal energy. So as gradually the ligand approaches, okay, still these energy it gradually increases, okay, it gradually increases, all of them equally increases, okay, but when they start forming your complex, that time what happens, there is a splitting takes place, okay, there is two level, that is your EG level and this is your T2G level, okay, this one has your dxy, dyz and your dzx, okay, and this forms your dz square minus y square and your dz square. So these are the two orbitals, okay, so there is a difference of energy, okay, and this difference of the energy is nothing but your crystal field splitting or your delta naught, okay. So this here there is positive energy. Why? Because this repulsion is taking place. So this is very much high, energy is very much high, and this side we call as your negative energy level. Okay, now we will derive. See, the overall energy, that is the sum of. So the overall energy, that is your sum of energies of the orbital belonging to your EG level and T2G level, remains unchanged as compared to the energy of the orbital before splitting. So before splitting, the energy levels of all the subshells, it is unchanged. Okay, so please note down this carefully. In the same form you have to write the derivation if it comes in examination. Okay, you have to write the same derivation. So see, before splitting, the energy level of all these are same. So what we can write, E dxy, energy of your dyz plus energy of your dzx plus energy of your dz square plus energy of dx square minus y square is nothing but is 0. Okay, so next, now what we will do is that now E dxy, okay, it's equal to E dxz is equal to dyz. This we know, okay, that is your T2G level, and we know dz square is equal to the energy of your dz square is equal to the energy of dx square minus y square. Okay, so therefore what we can write, this is your equation 1. Therefore we can write like this, your 3E dxy plus twice E dz square is equal to, here 2 is same, and also xy plus 2 is ed z square we can write is equal to 0 by putting it in equation 1, because we know all the energies of T2G level is same and EG level is same. So we can write like this, and we know the level of difference of between the T2G level and the EG level and the T2G level is your delta naught. Difference between your EG level, that is called your crystal field splitting after formation of complex. This is after formation of complex. Here we write this to be equation 2, and this one is equation 1 only, has rewritten in this form. Now multiplying equation 2 by 2, and what we are getting, if you multiply this equation by 2, we are getting 2 E dz square minus 2 E dxy is equal to twice delta naught. Okay, this is our equation 3, suppose if you write. Now, from equation 1, we have, if we rewrite this equation, what we have? We have 3e dxy is equal to minus 2 e dz square. Alright, so we have e dxy, we can write as minus 2 by 3 e dz square. Alright, now putting this one, now this value, substituting this value in your equation 3, what we will get if you put the value of e dxy, so we are getting, substituting these values in equation 3. In equation 3, if you put this value of e dx here, what happens? We get twice e dz square minus 2 into minus 2 by 3 e dz square, okay, which is equal to twice delta naught. So here we are getting twice e dz square plus 2 to the 4 by 3 e dz square, which is equal to twice delta naught. So now by this is same, but we have to take the LCM of it. So if you are taking LCM, it becomes 2 3s are 6, so 6 e dz square plus 4 e dz square, which is equal to twice delta naught. Actually, we are finding the relation between your crystal field splitting energy and the relation of any one of the splitting. So now what we are getting, 10 e dz square, which is equal to 6 delta naught, or e dx z square, energy of one system is your 6 by 10 delta naught, which is 2 3s are 6, 2 5s are 10, that is your 3 by 5 delta naught. Okay, so this is now substituting the value of e this z square in your equation number 1. Now, so we are going to substitute this, substituting these values in equation 1. In equation 1, if we put what we are getting, we know d e z square we have, so 3 times e d xy is equal to minus 2 e d z square, which is equal to minus 2 into 3 by 5 delta naught. Okay, which is equal to 3 e dxy. So 3 and 3 get cancelled. So your e dxy, that means your the lower orbital, and this is the upper orbital Eg level. This is your Eg level, and this becomes your T2G level. The difference here is your minus 2 by 5 delta naught. So what is the energy difference if we draw the graph again? So here the crystal field splitting, and the difference of this crystal field splitting is, here it is plus 3 by 5 delta naught, and here it is minus 2 by 5 delta naught. Okay, this is your Eg level, and this one is your T2G level. And delta naught is nothing but your CFSE. So this is your crystal field splitting in octahedral field. Okay, and this side is your energy graph. And this graph we will use, or we can say we are going to use these values to find different CFSE and crystal field splitting energy of different orbital complex. So these values you should remember, and it is going to help you to solve the numericals next. So I will take some examples also.